Hello to anyone tuning in on YouTube. Uh, I'm sorry for the missing audio in the last part of the video series. I didn't realize that my headset disconnected. It's a weird headset. Whenever I use the microphone continuously, it decides to shut off randomly. Maybe there's some erosion in the headset, especially the microphone. Anyway, uh, it doesn't really work as it's supposed to. Uh, yeah, sadly. Um, so yeah, we got cut off. Um, I think uh, so. In the last episode, we created a specific method for loading the DDS file and passing the information into a output data structure, which are arranged in 8-bit bytes. We check for sufficient memory, whether we have the correct file type. Every DDS file is prefaced with the text DDS whitespace, and then we check if the header is correct. It's supposed to uh, tell you the size uh, as a part of this data structure. If it's not the correct size, we also have an error. Then I realized that they might have changed the header file format. Um, in in later versions, so we also need to be able to handle that situation. Um, yeah, it allows you to use texture arrays, which are a part of the DirectX12. So yeah, um, we should definitely so it doesn't. Maybe it's DDS. No, it doesn't work. Anyway, which means we should check whether we actually have uh, a bit set for that. Let's see. I think it's the third bit. Anyway, let's see. So we have our flags. Uh, maybe it's not the flags that we read into. It's probably the let's see. It's probably Uh, the pixel format, where is it? Where is it? Where is it? Yeah, there. So since it relates to a different pixel format, see, uh, uh, this probably would have a flag. So let's see. Uh, so meaning that the underlying structure here contains 4 character codes. So if the flag is set, then we know that there. Yeah, so if this is set to DX10, it indicates that this header extends the header, uh, and this particular header contains the true format of the file. Yeah, so we have to check if the flag contains um, if the flag contains the bytecode, or rather the value 4. So we can do that by bitwise operations. So we do the header and we do the flag, rather the pixel format flags, and we end it with our value 4, and we print out some debugging information here. Found for CC flag. Let's test that out. Yeah, so we actually find the flag. Uh, and then we can check if this then this is supposed to be, and this, let's parentheses this, and then check if that certain structure is equal to something which we haven't specified yet. So it's supposed to be this string, and I've seen someplace else where they simply combine different combine different let's create a helper create for char bit and we pass in the A, B, C, D and maybe there's already a macro for it. Let's see. Let's just test that. Yeah, there's a macro for it. No reason to do a lot of work then. Let's see. The character is supposed to be uppercase D, X, 1 and 0. And then we end the parentheses. And let's check it out. We actually find the flag set as well. So that means that we need to check if our file at least contains at least contains the size of the header. Let's see, resource dimension there. So maybe we need DX10, D10, D3, D10. Is that the correct one? Yeah, it is. Okay. So now we need to check if our if our file content is lower than that. Let's see. I'm missing a parenthesis. There we go. We do not have enough. Does not contain the DX10 header extension. And then we return. Yeah, we don't need this debugging flag anymore. Okay. Great. maybe for ease of use, we would like to store some information. We could pass out some X's, but yeah, let's just wait a minute. Yeah, next uh, we want to load the actual texture. Uh, yeah, we want to load the actual texture. Maybe we want to return an 8 result. For that, load DDS texture from file, and then we take in the same thing. For now. Mm, it looks like whenever I loaded a DDS structure in the past, it would also take the actual output here and pass it back for reading from a buffer. Yeah. Maybe we actually want this to return an H result. Let's do H result. Unspecified failure, that is out of memory. All right. We have access denied, handle not valid. So file not found. File not found. Out of memory. Oh, whoops. Let's see. And then we return is okay. Yeah. Then we implement this. And we call this instead. And we call this method uh, so everything is supposed to run exactly. Let's just do a print and read DDS file. Let's do file name. Am I allowed to pass that in? No, I'm not, because it's not supported. Let's see. See out. Let's do std v out. Maybe it's in the same. Let's just do some helpers. Yeah. Our helpers printf file line. And let's do a print that doesn't make a new line. And let's do a print wide new line that's using v out see stream out. There we go. And then we would like a print wide that just prints whatever gets passed into it. There we go. We would like then for our caps. Mm-hmm. Uh, yeah, it's supposed to be fine. Let's do file name here. Yeah, so now and this is supposed to be followed by a new line. There we go. So we read the file. And we just check with the failed macro. If it failed, return the result. Otherwise, we would like to do something. Maybe we want to, at least the Microsoft one does it that way. So it calls a create texture method, which takes in these are supposed to be private, I think, because we would like for this to be the overall interface. So then we would like to call uh, or rather, let's just reuse it. We should probably pass in our data. And we would like our header being passed out of this function. So therefore, we want a header, not pointer since it will be stored in our blob. So we want a pointer to a pointer, header. Let's see. Let's see. No, This is not where it's supposed to be. It's right here because we get that information out of this function. There we go, which was also what I specified. Yeah. Is it just... It gets called... Oh, yeah, so we have a mistake here. Let's call it pointer to the header. There we go. Let's see. And yeah, we need to let's see, what is the file type? DDS header, pointer, header, info, or just header. We pass in this, and we of course instantiate that as a null pointer. Yeah, maybe we want a pointer to wherever the data start without the header, and the let's see, this returns unsigned long, long. What is the size T? Test. Unsigned long. So yeah, you can use size T for that. Let's see. There we go, size T. It just looks better that it's uppercase. Doesn't really matter. Let's see. Size in bits. Or rather, yeah, it's total bits, not bytes, right? Let's see. Yeah, it is bytes. I think it's byte size. Let's see, size of... Yeah, number of bytes. Yeah, so let's do size in bytes. So yeah, we Change this method. Pass out a const uint 8 pointer data data, and we do a size t of byte size. We wanted to store it at the data. This is actually a pointer to a pointer. Yeah. That is absolutely fine. We will just change that. Let's see. So, and this will also be a pointer since we want to pass this out of the function. Let's see. Uh, yeah, of course. We need to pass in the address of this variable. Here we forgot to add const. Actually, we would like that as well. Let's see. There we go. And then we, let's see. Did I? Missing type specifier somewhere. Let's see. Function does not take 5 arguments. Let's see. 1, 2. 4, 5. 1, 2, 3, 4, 5. I beg to differ. Oh yeah. So yeah, I'm missing a type somewhere. U8. Did I not specify that? Maybe doesn't it know what a size T is? Base SD. Let's try to include that. Oh well, no. I'm not entirely sure here. I mean, I'm missing something really silly. Yeah, let's just. So I changed this. Let's just copy the argument list because I might have made a typo somewhere. Let's see, does this compile? No, it doesn't. The types are maybe maybe this needs to be included in this because it doesn't. No. What the fuck am I doing wrong? Uh, I know. It's because the header file doesn't know what these things are, meaning that we have to move them into the header file, which means I would actually like to enclose this into a separate namespace just in case. DDS. And move all of this into a namespace. DDS. There we go. Yeah, and we also need to move that into here. There we go. Yeah, so the compiler kind of tried to tell us that we were not elaborating on what argument we were passing in. It was forced to assume an int, which is not true because it didn't know the so I'm just gonna set a flag here to true. Then we tell our pointer to point at our header. The pointer to the pointer. Yeah, the first pointer is dereferenced, and then it's supposed to point to this part of the data structure for the header. Then we need a size t offset, which is equal to, let's see, we need to calculate it from our header, meaning that we calculate it like that, plus if we have this header, if it's true, we add this, otherwise we add 0. And then the pointer to our data, dereferenced, is equal to our output data pointer offset by our offset. And this size is equal to byte size in bytes is equal to our info end of file low part minus the offset. There we go. So we would like to step into our function here. Well, something didn't work out. Well, well, there's a parenthesis around all of it. It doesn't need to be. There we go. So we test out. Although everything gets set, then we know our byte size. Our data. So yeah, our header structure gets initiated. That is set as well. Let's see. Yeah, the byte size gets set as well. It's a bit less than the first bytes, which are probably 132 bytes. I'm not gonna do the math, but I'm just gonna assume it. All right, so we get our information here. Yeah, and we will reference that information in the next part. Excuse me. Yeah, so we need to pass in our header, data, and byte size. So this needs to take something to the effect of a header, some data, and the byte size. There we go. Not in the declaration, here in the definition. There we go. Wait a minute. It has to be const as well as const here, and const because we do not intend to change any of this, also indicating that whatever goes out is fairly easy to determine. Yeah. Now we can start filling out a texture structure here. Let's do the same here. Let's see, what do we get of information from our header? Let's see, I had a tab open with that DDS pixel format. So let's check out the header. Size. Surface width, so we can get our resource information. So we can do a unsigned integer called width, which we will get from our header. Width, our height, which we will also get from our header. We will get our depth, Uh, and as you might start to see, this corresponds to our texture information, or rather, we haven't seen the actual texture structure, but if you just think of the way uh, um, a regular buffer is specified in DirectX 12, for instance. Let's do resources. A regular buffer has a array depth or array size. It's because DirectX 12 and probably other versions of DirectX support 3D textures, meaning that not only do we have a width and height, we also have a depth. Um, and since we already opened it, we know that we need to set the MIP levels. So let's see. Let's just do a uint MIP count. Can this be otherwise unused? So it might be initialized as 0, which isn't great. Which isn't great. Which isn't great. So if it, because since we're dealing with a texture, we will always have a MIP count of 1. The MIP count is how many sort of scaled down versions of the texture it contains. So it will always contain the texture itself, meaning that we will just hard code that. Then we need to, let's see. So we have the depth and array size. Let's see. Yeah, then we need to check if we have the extended headers. So we're just gonna copy this and instead check the header. Mm, yeah. Then we would like to store the uh, um, header extended. Extended header. Let's just copy this. And we would like to increment the pointer of the header by shifting it with the size of that structure, but right now we do not have a base pointer. We could recast the header pointers, which we want to offset as a const byte pointer. And add that to it. Let's see if we can stop here. Well, that doesn't happen for some reason. Let's see, do we end up here? Yeah, we do. Oh, we did, let's see. It's just invalidating test it before. Let's see, extended header. So we have the DXGI format here. Let's just store that. Format is going to be format unknown. What else do we have inside our extended header? Array size 1. It also has the resource dimension. Let's do AD3D12 resource dimension. Resource. Let's see. What else? Whoops. I did something. Whoops. I'm totally messing around, yeah. So, what else can we take out of our... So we get an eraser, so I'm not sure whether we actually need that because the depth... let's see, equals 1. Maybe we use it anyway. Seems like we can extract that. So we got the format, resource dimension, and the array size. So we store that. Array size. Let's see. Array size. Yeah. So cube mapping is by employing 6 textures to each side of the cube. Therefore, if it's cube mapped, the array size will be 6. For a 3D texture, you must set this number to 1. So it's probably going to be... Yeah, there's a lot of debugging features that we could implement, but we're just gonna set the array size to 1. Right now we're just gonna trust whatever we get passed. So the format is equal to the extended header, the XGI format. Yeah. We need to extend this eventually. Uh, right now we only support the classic 2D textures. So we store a... This is stored in probably, let's see, extended header, resource dimension. Nah, yeah, We need a cast to that. Otherwise, if it's old school, we set the format to the header format. Yeah, okay, if it's old school, we probably won't support it for now. Yeah, we just got age result not supported. Yeah, we just return some random failure. Operation aborted. That seems fine. Uh, uh, Then yeah, we could do a lot of error checking. Anyway, uh, then we need to actually pass the data. Let's see. Yeah, you were supposed to for 3D texture set that as one number of resources, which means that if our resource dimension is equal to a D3D resource 3D, we assign one, otherwise we assign our array size, meaning the amount of textures uh, then each layer may have a specific MIP count, meaning that we increase the value by the MIP count. Let's see, I'm just gonna look up the structure feature format. Uh, there's some checking of number of planes. I'm not sure what it does. So yeah, It, yeah, okay. It's if it's okay, seems like we need to pass in a device to check the number of planes for the particular format. Let's see. ID 3D12 device pointer. Add that to this as well. And add it to that as well. And add it to the default constructor. Or rather, not default constructor. Whoops, needs to go away. Yeah, and then we need to pass in our device. There we go, everything should be fine. Yeah. Let's see. So now we can ask our device. Let's do AD3D feature format info, which takes our format and a plane count of 0. Feature data format info, and we ask our device. Feature format info or format info structure, and with the size of feature format data format info. Let's just wrap this. If it fails, We return a failure code. Otherwise, we check the planes here. Let's see. So the failed parentheses. Okay, I need another parentheses. The format info. And it has a plane of 1. Now we retrieve it, so therefore I'm just gonna use it. Plane counts, yeah, in case we need this. Yeah, I actually don't think we need this right now. It's for error checking. Then we create a vector of D3D12 sub resources, or maybe sub resource data. Is that? Yeah. Sub resources. We reserve data for that, for a number of resources. Let's see. Then we need to get our data. Let's see, let's see. Then we would like to read our data. Let's see. Let's move that up there. We can actually move this into a pragma region graveyard and leave it for future use as to not clutter anything here. So we will only support DirectX 10 specific textures for now. We will instantiate a constituent pointer to our source. We will calculate our end point. We will set an endpoint. Endpoint. Source point. Equal to our data. Is it what I called it? Yeah, our data. To our data plus the byte size. So we have a start point. Maybe we call it that instead. Yeah, I would like to have a breakpoint here to see whatever information we have. We have a height of 600. We have a width of 800, which is corresponding to the extra texture we created. We set the array size to 1. The format is where our format BC7 unorm. I'm not entirely sure what that format is. Anyway, the MIP count is 10. So if I do NVIDIA DDS texture tool, there it is. So whenever I drag the image into the texture loader, it decided to create box 10 MIP counts. We also update that, right? Yeah. Then we have to pass the format. Let's see. So we will handle different formats eventually. Let me just see here. We could handle different formats. But right now we just need to know how the data is stored. Yeah. Yeah, we need to calculate how many number of rows and number of bytes per row. Let me see, just look up an old version to see what format it is in. Oh no, not that. That's the old version of that. Let's do textures and open that in Visual Studio. So yeah, texture formats. Let's look up some texture formats. DDS texture formats. So let's see. All right. This is somewhat daunting. Let's copy this format here and just look it up. Yeah, so it's compressed. Fixed block size of block size of 16 bytes. So we will only support the compressed formats. Right now we will only support this format, meaning that the blocks are 16 bytes. And tile sizes of 4. So we can calculate the information in this specific this specific texture that we've loaded. Yeah, you would get way better support by just using the pre-developed DDS loader, which comes with several libraries, but yeah, we're committed to not doing any libraries and walking through whatever we need to do. So uh, block size, let's see. Maybe we don't need to store that in a the block size is 16, as we saw in the documentation. Then from our width and height, we calculate how many tiles we have. So if our width is higher than 0, which it probably would be, but anyway, maybe it's arranged in another way where it for some reason has another orientation. We would set the num of blocks width. We would set that to whatever maximum we could get out of. We would return a uint64, and we would either return 1 or a uint64 version of our width, added with 3 to yeah, offset any decimals, and then we calculate the number of blocks in the width. We do the same for the height. And there we go. Yeah, and then we have bytes for each row equal to the number of blocks width times the block size. And we have the number of then we have the total number of bytes, which are equal to our bytes for each row times our height. There we go. Let's see. Mm-hmm. All right. Yeah. Mm. Mm. Well, we have to pass the data. Let's see for int I, no array equal to, while a is less than array size, we increase a. So we do this. Maybe we do this before. So starting out for each array, we have our, so we have our start point and our end point. Then we let's see. Let's see, and we do a uint32 skipped MIPS equal to that. Then where did I? Yeah, I moved that. And then we iterate through the arrays. Then for each MIP, we go through the same. Let's see, MIP count. Oh yeah. So actually we need to calculate that every time. Let's see. Bytes for each row. We will just move that up here. Set that, and we will also set that, and we will stop redefining it. And actually, we will do this calculation each time. But as I can see here, we will have a uint32 called width, which is equal to our width, uint32 height, which is equal to our height, and then uint32 depth, which is equal to our depth. And we will use these values instead. Let's see. Since we will bit shift them, then we will, if a is equal to 0, we want to skip the MIP. Each array could have only one MIP, so you could do handle if array only has one MIP. We increase the skip MIPS. We check if we have overflown. In that case, we return an error. So if our starting point plus the number of bytes for each row times our depth is larger than our endpoint, we return a failure of sorts. Let's just return an out of memory. There we go. Maybe this will give us problems, so let's just rename this to size T. Also, maybe this is fine in a size T. All right. Let's see, we should recalculate the number of blocks. Rather, we actually need to um, mm, mm, um, Yeah, we calculate, let's see, else. If the MIP count if the MIP count is lower than or equal to 1, or otherwise if we just happen to, this is unconditional, meaning this will should never be run as is. Uh, we're getting close, we're getting close. So you're allowed to limit this in the original by a total size. The MIPS are dynamically allocated in terms of so yeah, for each MIP we will just add some sub-resource data, which will be our start point. Let's see. Let's fill this out in another way. Fill out the res pointer to the data, which will be our start point. And our row pitch, meaning, let's see, row pitch is the first one. I think this is correct, if I'm not mistaken. So for each MIP, this will be recalculated. So we need to update our information here. Let's see. Let's add this to our sub resource. And then if we overflow, we throw an error, we increase by the number of bytes. No, the total number of bytes times our depth. And then we reassign this bit shifted 1. The height is also bit shifted by 1. So that is divided by 2 as far as I remember. So if we do 16 and bit shifted by 1, yeah, by 1, yeah. So we divide by 2 each time. And if it ever gets to 0, we just set it as 1. Whoops. There we go. They do a smart check here by saying, is the data empty? Then we throw a failure, otherwise we return OK. Let's see down here. Let's just do a print new line. Ran through DDS stuff without a prob. Yeah, so we actually succeed. Yeah. I would like to step in here and see our sub resources, and they get halved. Skipped MIPS is 0. So we have 10 MIPS, which is equal to our MIP count. First MIP is there. The pointer is offset. I think we are getting really close. Let's try to create a resource here. Well, yeah, this takes a device, so we can actually do it in here. Let's see. Let's see. Yeah, the whole system has a lot of flexibility and error checking. For the scope of this project, uh, um, we're definitely gonna not gonna implement all these features. This is just meant as a sort of A to C tutorial through whatever to do in terms of uh, if you want to understand, at least I'm not explaining it very good, but what happens under the hood in these programs. And I've kind of like decided on just doing um, almost everything from scratch, even though it takes a long time, because it helps me to understand what is actually happening in the entire engine. I even wrote the OBJ reader. Yeah. Uh, let's see up here. We do a check on the resource dimension here. Remember that the array size will always be 1 if we have a 3D texture, and we will use our depth, or otherwise we will use our array size. Our format is our format. Our flags are DCD none. Our sample description count is 1, and our let's just do like this, 1 0. And let's do the dimension, which is our resource dimension. And let's do a default heap. The 3D default heap. And well, actually, we need a com pointer to store this in. Right now, we will do a ID 3D12 resource resource. We will just do it for now. Create committed resource. We will store our heap properties. We will create it with heap flag none, and we will create it with our resource description here. Let's try not to overlap these things. There we go. And the initial state is common. We don't need a clear value, and we want a EIIDD PBRX resource dot get address of. I'm still missing something, probably a parentheses of sorts. Yeah. All right. Let's do a test value in our renderer. We do a texture test. We do a ID 3D12 resource pointer, P resource. Wait a minute, yeah, we just store that for later before I clear my clipboard. Whoops. There we go, and we pass that along into our thingy here. So yeah, we have to readjust the constructor, and we pass in the p resource. We pass in it here and here, and we pass in the resource pointer, and then in here we pass in the get function. All right. Lastly, we do not pass that in, we pass in the p resource. Oh, wait a minute. Okay, we do this manually then. The interface, and then we reinterpret cast it as a double void pointer, p resource. There we go. Let's see, does this compile? It actually does. And let's check out NVIDIA Insight here. Of course, we have to make sure that everything is up and running in terms of information. Oh, I'm in the wrong directory. Texture, let's just drop that in here. And all right, also in a moment's time, it will be time for a break. No file found. Well, I'm sad to hear that. It doesn't think it found a file. directory. Huh? For some reason it doesn't work. Oh well, I just had to recompile. Let's see. No, that is our scene. Have we not created one? Let's see. All right, we're not succeeding here, I think. Let's if failed here, we would like to do something. Return the failure. There we go. So well, am I supposed to pass a com pointer? Let's try that instead. Maybe. So if I get to here, the P resource is supposed to be a 0. Uh, um, let's see the resource. Yeah, maybe I try passing the com pointer. Maybe it just goes out of scope. So let's do Microsoft instead. There we go. Let's fix it inside here. because maybe it needs to be able to initialize it. Let's see. Yeah, so instead of that, we do ID, PPV, args, P resource, get address of. And are we having one too many? Yeah, we are. Or one too few. Yeah, one too few. Let's see. Where is the error? Oh, it's not an error, it's a breakpoint. Let's see. And we just pass in the com pointer. So now it has an internal pointer. Yeah, I think because we were supposed to give the address of the resource. Yeah, we just cast it to the wrong type. That is why it didn't work. Anyway, let's compile this. It still works fine. We do inside graphics, and hopefully now we can see our texture in memory. Let's see, all resources. Well, still not yet. That is not great. That is not great. So whenever we start here, let's test this out. So the texture test is nothing. Afterwards, the texture test is still nothing. So let's see, is it because the constructor doesn't do what it's supposed to do? Let's see, the constructor calls the texture load from file, and we do end up here. But is it because we copy the resource pointer? Yeah. Maybe we want to pass in a pointer to the com pointer here. Let's see. And so then we need to dereference this and get the address of it. There we go. I know this is surely not how it's supposed to be, but Let's see if we can. Let's do our texture tests stuff here. Now it gets created. And yeah, so that was probably the problem, that we were copying the com pointer, which is not helpful. There we go. Because it doesn't really make sense to copy a com pointer. Let's see what's happening. Oh, okay. I messed around. There we go. And then, yeah, our texture is loaded. It doesn't have any content, but it does get created. Let's see. Yeah, and it creates all 10 MIPs. Doesn't copy any data. For some reason, it is all black. Uh, but we do create the correct texture. So that's a start. Now we need to do debugging in terms of why doesn't it show us anything, because our texture is loaded as something. Yeah, okay. So maybe we missed something. Oh, of course, I haven't copied the actual data. Yeah. There's nothing uploaded. It's just created. So yeah, that's the next step, to actually upload the information. Now we have the layout. Yeah, so last thing, we need to pass out the sub resources. So we need to, instead of passing this in, we will actually do it outside the application, or rather the loader. So we will get the data here, and we will get the sub resources here. So whenever we load the DDS file, we get the actual data, and we get how the data is arranged in terms of which sub-resources it contains, starting with the original image and then going through each MIP, as you saw here in the texture, going through each MIP. Yeah, I'm getting really close to a point where I need a break, but I just want to round off this part of the series and then go do some stuff that I need to do. Welcome, Ella. Let's see. So we finished this up. meaning that we would like to pass in a reference to some sub-resource data, which the function will spit out, so to speak. So we sub-resources. So we add that. We also rename our let's see, I want to rearrange this so it makes more sense. I would like to call it out and we would like to call it first by the file name, then the device, then the out data, and then out sub-resources. All right, now it gets more clear what our function does, meaning that the last three parameters are specifically something that gets passed out of the function. So let's just rearrange this. We will do the same thing for the public method. So we will pass in the file name, the device, the out resource, the out data, and the out sub-resources. There we go, and we will fix this method as well. No, that's not needed to fix. It's down here. No, not that one. This one. Yeah, that is supposed to be arranged like that. And we do out resource, or rather, nope. So we do our out data here and our out resource. We would also like to rename these different things so that everything gets more clear. Yeah, like that. And actually, I would like for this to be far up ahead after the constructor, since it's the public functions. We have a problem here. Let's see. Did we? Yeah, we did rename these. The signature probably works still, but there we go. So let's just rename this. And we call it out data. Let's see. All right, this is still an error, but that's fine for now. And we copy this and look up the method. change the variable names. Let's see. Then we need to update whatever that is, and we need to call this p out resource for now. We will definitely change things around whenever we whenever we uh, whenever we implement the last bits, or rather last parts. Yeah, I would actually like for these to be last in our parameter setup, because these are values going in. The real ones are values going out. Yeah, so let's see. This also needs to get swapped. So first we pass in the device, we then do our p out resource, then our out sub resources. There we go. And then we still need to fix that, but we added the out sub resources vector reference. Thereby we add data to the vector, and everything should be fairly okay. No, not yet. So yeah, of course, yeah, I need to probably rearrange some of these constructor values. Let's see. So I pass in the file name, the device, then the resources, first the actual resource, then the data, and yeah, okay. So I think I need to swap this and the device. Yeah, and let's see, did we create the expected resource on our GPU? Yeah, we still have our resource that have 10 MIP levels and the correct setup in terms of width and height. Yeah, and it's created on the default heap. So now we can actually use this data, the raw data, and the instructions about how the sub-resources are arranged inside something like a, let's see, linear buffer like this one, where we actually upload the data to each sub-resource. Yeah. Let's see. Maybe we are allowed to do it with our current system. We can test that out, even though it might fail. Let's see. Linear buffer queue upload, and let's. Oh well, we do not have an overload for a D12 resource. And a texture resource. Well, maybe we could get around that. maybe we could get around that by, instead of doing that, we do a D12 resource, which is our own type, texture test2, and this will also hold an empty com pointer, and it actually inherits from the com pointer, so this is probably fine. Then we wouldn't like an offset, and we would like to give a reference to our data, and we would like to create, let's see, take our sub resources, the first one, and actually pass in the slice pitch. I'm not sure if this is going to work, but let's just test it out. We could actually, instead of that, just pass the pointer data in, cast it as a void pointer. Doesn't matter. There we go. So syntax missing before return. Yeah, okay. And then we do the upload. So far, no errors. This should upload, if it works at least, this should upload our first part of the mapping of our texture, meaning our base texture. Well, it doesn't work. Let's see. It's because I have to do something else when it's texturized. I think, at least. Yeah, I maybe have to copy this sub resource instead. We could try something else here. Copy. Maybe if we get our graphics command, let's see. Let's close this, close this, close the freeing mechanism, then copy texture region. Oh yeah, that's how you do it. Oh well, we will get to that in a future video. For now, I will be having a break, at least for a while I do some different stuff that I'm supposed to do. Maybe later on I will continue on actually uploading the texture. I will definitely do it later in this series, but whether or not I get to it today is something that I'm uncertain of. Yeah. But as you can see, we actually are able to create the raw data structure from our DDS file, which we created manually by using the NVIDIA Texture Toolkit. So we just need to upload the raw data, which we were supposed to do anyway. So yeah, we will probably, maybe we want to use our linear buffer and just cue a texture on it instead. Yeah, because the principle might be the same, or will be the same somewhat. Anyway, the graphics command list prompts are just different. Yeah, maybe we will implement it in the same system. Yeah. Anyway, hopefully you found any of this helpful. If you did, feel free to comment, like, or subscribe, or follow here on Twitch. Yeah. Yeah, you can find most of my work in on the YouTube channel. Also linked here on Twitch. Yeah, there are some missing videos, but yeah, as I've mentioned previously, I can always fill in the blanks if someone needs me to. Anyway, thanks for watching. Hopefully I'll be seeing you around. Have a great one. Bye bye.